Good morning, one and all. This is Varkanat SK, Assistant Professor, Department of EEE SJBIT Bangalore. Welcome to today's session on tower support based problems for the course Transmission and Distribution for the 5th semester students with the subject code 21EE51. So let us know more in detail about the role of sag over here. So as we all know that when a rope is suspended between the 2 points, there is a tendency to sag it down. Similarly, when a conductor or a wire which is suspended between the 2 points, the wire will be sagging down. The wire takes the shape of the catenary or the parabola. Okay, so this sag plays an important role in the mechanical design of the overhead transmission line. So, as we all know that the definition of a sag goes like this: the difference in the levels between the point of support and the lowest point on the conductor, we call it as a sag. So there are two cases over here with equal support and unequal support. So let us see the problem. We are very much more interested with respect to unequal supporting. And unequal supporting, as we all know that the sag is given by the formula with the x1 and x2 the cases, which is L by 2 minus TH by WL, and x2 is equal to L by 2 plus TH by WL, where x1 and x2 are known and sag s1 and s2 can be determined over here. So let us take a numericals with respect to it to solve the problem. So the two towers of height given is 95 meters and 70 meters respectively. They supports the line conductor at a river crossing. The horizontal distance between the towers is 400 meters, while the tension in the conductor is 1100 kg and its weight is around 0.8 kg per meter. So we need to calculate sag at the lower support, sag at the upper support, and the distance of point of contact on the trajectory from the water level. So if you look at the diagram over here, the point O, point A, point B. Point A is the lower height, point B is the upper height. It is from A to O, the distance we call it as sag S1. From B to O, we call it as S2. The difference in height between A and B, we call it as an H, and it is given by 25 meters. That is nothing but the height of the tower A, 70, while that of B is 95. The difference is 25 meters. So overall length is given as 400 meters. Tensile strength is around 1100 kg, and weight of the conductor is 0.8 kg per meter. So as we all know that the x1 and x2 is given by the formula. X1 is L by 2 minus TH by WL. On substitution, the value of length as 400, tension as 1100, height is 25, weight is 0.8, and overall length is 400. We get x1 as 114.0625 meters, and x2 is equal to L by 2 plus TH by WL, or we can make use of length minus of x1. We get value 285.9375 meters. So from the value of x1 and x2, we can able to find out the sag at the lower support and at the upper support. So sag at the lower support S1 is given by the formula W into x1 square divided by 2t. So W is known, x1 just now we have found out 114.0625, tension is known. So we get sag at the lower support as 4.731 meters. And sag at the upper support S2, which is equal to W x2 square divided by 2t. So on substituting the value of weight x2, just now we found it is 285.9375, the square divided by 2 into the tension is 1100. So we get S2 sag at the upper support is 29.731 meters. The point B, which is at 95 meters above from the water level, while the point O, which is at the lowest on the trajectory, so 29.731 meters down from point B. Hence, the clearance of point O from the water level. So this clearance is nothing but this height minus of this height. So 95 minus of 29.731, this is not equal. 95 minus 29.731, which is 65.2689 meters, or we can also take from the lower support height of A minus of O. So height of A is 70 minus of 4.731, which is 65.2689, which is at the same. Okay, so this is the sag at lower support, sag at the upper support, and the distance of the lowest point on the trajectory from the water level. Okay, so hope the students might have understood the tower related problem with respect to unequal when it is transmission conductors are placed at the river crossing area. So thank you one and all. So any doubts, any queries, you can reach me on dwarkanath@sbd.edu.in. So you can watch out for subscribe for the department channel to get more videos and updates on it. Thank you one and all.